Alright class, so here's the part 2 for the test. We're going to go ahead and simplify this radical. So we want to try to take out as many perfect squares as I can from underneath the radical. So I'm going to do square root. Now 80. So for this one, I know for 80, I can probably do, let's see, I can start with 81. That's, well, not 81. 7 times 7, which is 49. That's not going to go in it. Then 6 times 6, which is 36. Nope. 5 times 5, which is 25. No. 4 times 4, which is 16. And there you go. 16 works. So I'm going to go ahead and break down 80 by saying 16 times 5. Alright, and then for this part right here, I can only take out even numbers because this is a square root. Remember that there is a 2 right there. We don't usually write it, but it's there. So it has to be divisible by that number. So I'm going to take the 9 and break it apart by saying 8 and 1. I can write the 1. I really don't have to. B squared, 2 can be divisible, so I'm just going to leave that part alone. And then for 25, I'll make this a 24. So, because C is 24 is divisible by 2, and there you go. All right, so let's start taking out some perfect squares. So 16 is a perfect square, so square root of 16 is 4, so that comes out of my radical. I'll leave that alone, that stays under the radical. So this one, a to the 8th, it means that for every 2 I can take out, so there are a to the 4th, because I can do 8 divided by 2 gives you the 4. That's done. Leave that alone. So over here, 2 divided by 2 is 1, so I can take 1b out. And then C, 24 divided by 2 is 12. And then I took that out. So what do I have left underneath my radical? I have 5, A, and then C. So there you go. B. Okay. For the next one, I'm going to go ahead and show you this. So same type of process. I want to see how many perfect cubes I can take out of there. So I don't really remember my perfect cubes. So let me see. I'm going to have to use Desmos' help here. So let's say I'll start with 6 cubed. That's 2. I don't think that's going to really work, but let's see. 2, 1, 6. Yeah, it's not going to work. So let's see what 5 cubed is. 125. Let's see if 125 works. Yes, 125 works. So which means that I can go ahead and break this down to say 250 is equal to 125 times 2. Okay, and then the 6, I can take, it has to be divisible by 3 because for every 3, 1 comes out. So I can say, I can leave 6 alone because I can do 6 divided by 3. And then, but 10 is not divisible by 3. So I have to say maybe 9 because 9 is divisible by 3 and then leave 1 remaining. Okay. All right, let's start taking out the perfect cubes. So cube root of 125, well, it's 5. Right? So that's 5. That comes out of my radical. So here m to the 6 divided by 3 is 2. That comes out of my radical. And then 9 divided by 3 is 3. And that comes out of my radical. And then what do I have remaining? I have 2n. 5. There we go. To be just careful because they all look the same. All right. For this one, I can only put the same radicals together, meaning that I have to have the same number underneath the radical. So I'm going to have to break down 50, or simplify it, I should say, plus. So for 50, I can do square root of 25 times square root of 2, because 25 times 2 is 50. And then square root of 25 is 5. Bring down the square root. So this simplified down to have a square root of 2. So they do have the same square roots, which means I can go ahead and put them together by adding the coefficient. So 13 plus 5, that's 18, square root of 2. Same process here. It just seems like I need to go ahead and simplify both of them. So I'm going to say for the first one, I know 9 goes into 63. So square root of 9 times square root of 7. I'm not too sure, actually. I am sure. I don't know. Actually, square root of, what am I saying? Square root of, yeah, there you go. 9 times 7 is 63. I kind of doubted myself. Minus 2 square root of 4 times 7, because 4 times 7 is 28. Okay. All right. So then now this is 11 times 3 square root of 7. So that ends up being 33 square root of 7. Minus 2 times square root of 4 is 2 square root of 7. 2 times 2 is 4 square root of 7. And then 33 minus 4 is your 29 square root of 7. There you go. Okay, so this question right here looks pretty weird, but maybe it is. But let's see. What I'm going to do here is I'm going to go ahead and multiply the outside. So I'm going to do 4 times 3. 4 times negative 3. So that's going to be negative 12. 4 times negative 3 is negative 12. That's the coefficient, or the numbers on the outside. And then I'm going to go ahead and do the same thing for numbers on the inside. So I'm going to do 5 times 15. I believe that's 75. I did this problem so many times today. I forgot. 5 times, yeah, that's 75. And then x to the 4, 5, 6, 7. There you go. Okay, so now I'm going to go ahead and simplify square root of 75, which is square root of 25 times square root of 3, because 25 times 3 is 75. And then same thing here. I'm going to go ahead and take out 6, because I can do 6 divided by 2, and then I'll have just x left over. All right, let me see what I can do here. So that's 12 times square root of 25 is 5, and then leave that alone. And then you have x, 6 divided by 2 is 3, and then there's nothing I can do there. Negative 12 times 5 is negative 60, and then x cubed, I'll just put all of these together, and then I'll put these together, okay? So that's going to be square root of 3x. There you go. And then the last question. I told my class just to kind of throw this in Desmos. It'll give you the answer. But for this video, I'm going to show you how to do this without just putting it in Desmos. So 25. So I'm going to say this is square root of 4 times square root of 5. Because 4 times 5 is 20. So then that would be square root of 5 over 2 square root of 5. And then what happens here is these two get crossed out. They divide each other out. So that's just 1. So that would be 6 over 2, which is equal to 3. And honestly, if you just put this in Desmos, since it doesn't have any variables, it'll reduce down to 3. Okay? All right, thanks guys. Good luck on your test. Bye.